Alright, in this video we're going to look at another example of separation of variables, this time looking at the Laplace equation in cylindrical coordinates. So part A says assuming axial symmetry, that is, the symmetry with respect to the z-axis, no dependence on theta, show that if u of rz is equal to r of r z of z, then r and z satisfy the equations, that and that. So it gives us the answers. Now, I want to point out that it appears that our separation constant is negative lambda squared for part A. This, don't worry about that. It's based off of, it doesn't matter what you set it equal to for now. You can just set it equal to lambda. But the issue is why it's set to negative k lambda is because typically it's used because, according to ChatGPT here, I had to look this up, negative k squared often leads to solutions that are physically meaningful and appropriate for this specific problem. Because apparently, it's apparently influenced by the boundary conditions that are bounded at infinity. So it probably has something to do with the initial problem with it having no dependence on theta. That's probably why. Obviously, I don't understand that necessarily, but it is what it is. So let's start off by plugging things in. So we'll have r double prime plus times z plus 1 over r prime z plus 1 over r. U of theta in this case would be 0. So that term goes away. Plus z double prime, well, r z double prime. Divide everything by rz, right? We are left with r double prime over r plus 1 over r prime over r plus z double prime over z is equal to 0. Okay, so now we can move that z's over. Is equal to our separation constant, which will be this for some reason that we don't know. This is what we have to use. So then we have negative z double prime over z. Then let's see. We have our two equations here, right? So we have, if I move them over to that side, they'll be, well, one will be negative, one will be positive. So we can have this. Oh, z lambda squared z. I think that was a solution, right? Yes, it is. And the other one, multiply everything by big R and multiply everything by little r. This will be lambda squared big R little r, or I would prefer to do little r big R. And that is exactly what they have. So that's the answer to this one. Now we're going to do it, part B, with theta involved now. So we're going to have 3 variables to worry about, which is a new occurrence, right? So we're going to have r theta z, yes. where we have big R, little r, big theta, little theta, big Z, little z. This would be R double prime, theta, Z plus 1 over R R prime, theta, Z plus 1 over R squared, R, oh brother, R, theta double prime, Z plus U of ZZ, well, with that it would be R theta double prime, Z double prime is equal to 0. Let me fix that, that's bothering me. Okay. We divide everything by R theta Z. Yes. This would be R double prime over R plus 1 over R. R prime. Yeah, that's it. Over R plus 1 over R squared. Theta prime, double prime over theta. Plus, that would disappear. We're left with Z double prime over Z. So you see, we have 3 different variables. So that means we are going to have 3 equations. And in this case, 2 separation constants. Right, so first one, we can look at the Z one first, why not? Minus Z double prime over Z, and we'll set the first separation constant as lambda. So in this case, I need another page. Okay. We would have the first, that would be Z double prime if I move that over, positive, because it becomes positive, plus lambda Z is equal to 0. So this is one equation. And then we remove that side of it, and we'll just look at this part over here now. And we'll move this over to here. This will be equal to, this case we'll have sigma. Well, actually, hold on. No. You can't forget about the lambda. It's still equal to lambda, right? Oh, I forgot the, this here. We can multiply everything by R squared. So then this would be equal to oh, sorry, plus this over this is equal to lambda R squared. Subtract the lambda R squared over. Set that equal to 0. We're going to move this plus plus, not h, theta over to the other side. And we're going to add in a new separation constant. I will use sigma. Negative theta double prime over theta. So this is definitely a longer one, right? We now have two more equations. Let's look at the theta one first. So we have theta double prime plus sigma theta is equal to 0. And we also are going to have r squared plus r double prime plus r prime minus r lambda r squared is equal to, so that we minus r sigma is equal to 0. So that should be the full answer, I believe. Let's see. Oh, they left it on the right? That's the same thing. But yeah, that's what I got, right? So that's it. They just left the r sigma on the right.